welcome to our keynote today. It's the Wednesday keynote, second day on JCON. We had so much great sessions already. I'm super psyched. With me is Markus. We will get to his keynote in a few minutes, but before that, I would like to thank all of you for being here. We appreciate that you joined JCON today, and we think you're gonna have some fun and learn something new. We have so much great sessions for you. You can join the sessions today after the keynote again, and then we will have sessions tomorrow, and on Friday we will have workshops for you, so you can dive even deeper into all of the good things in Java. So this is really great because yesterday we cracked our 80 countries boundary. So we have over 80 countries now here at JCON, again, 6 continents. The 7th continent is really hard to do. So if you are in Antarctica next year, please let us know and join JCON so we can do the 7 continent thing. And with this said, I would like to thank all of our sponsors that make JCON possible. Also, Microstream is also a sponsor, so thank Markus too. And this is really great. Please check out their websites, their products, and make sure that they feel that investing in JCON and in the Java community is worth their while. From our side, I have a great announcement. As I said yesterday, for those of you who haven't been here yesterday, again, we are really excited that we can share that there will be a JCON people in person in Germany next year. We already secured the date, so it's June 20th to June 23rd. And this is going to be great. We will see each other again. We can meet each other again. This is going to be a real good conversation. And then we will have, again, JCON online. For those who cannot make it to Germany, we will have in the fall, in November, an online conference again. So this is also going to be great. One more thing from an organizer's or speaker's view, we have a feedback channel for you, and it would be really great if you could click one of those icons for the keynote sessions and for every other session that you attend, and give the speakers and us as organizers a little bit feedback. This helps really a lot. Tell us what is good, what could be improved, and we would really appreciate if you typed 1 or 2 sentences in the little box and not just click the smileys, because then we don't have the context for that. With that being said, it's my great pleasure to welcome Markus. You have a really fun title on your keynote. So you tried a Star Trek pun, I guess. Is that correct? Is warp 36? Is this a warp speed from Star Trek, or what is it?
So you're really right. So it's why my kids they look Star Trek all the time. So I'm more a fan of Star Wars, but so I cannot convince them. But I've heard that warp 36 should be the fastest, the fastest warp speed that's possible. So this is why I choose the warp 36 in my session title.
Okay, thank you, Markus. I don't want to start a geek war about Star Wars or Star Trek. Me on my side, I'm a Star Trek guy, so we'll let you pass for today. That's okay. And next time you can't come to the conference if you don't commit to the Star Trek universe, okay?
Thank you very much.
Okay. Yeah, the stage is yours, Markus. Take away.
Thank you for your great intro. Thanks, Richard. Yes, so I choose the term warp 36. It's because it should be the fastest possible speed. And so I am convinced that with Java, we can reach it. So this talk is all about Java in-memory data processing and building the fastest data processing app with Java, and promise there are no more Microstream sessions on the conference because we have no more marketing budget left. So now the JCON organization has all of our money. So that's the last one, at least for today. So my name is Markus Kett, and I'm CEO at Microstream, and we work on Java development environments. Like Rapid Clips, which is based on Eclipse, and on persistence tools, the JBoss Hibernate tools since more than 15 years. So to clarify it, so we are not contributing to the JBoss Hibernate tools. So we are trying to improve and to improve them and make it more convenient to use it. And also we built a framework based on Hibernate to simplify database programming with Hibernate to offer a development environment for Java developers that are not professional Java developers. They start from with Java, coming from other programming languages like Oracle Forms or other 4GL development environments, want to move over to Java. Now, this is our passion, and so we love what we do. And this is also the reason why we then have started working on serialization and persistence. It's because we wanted to simplify and accelerate database programming and also to accelerate the applications. And the reason is why we all want all the time work on new innovations, on the applications of the future, then the next big apps. And we want to improve the customer experience, building beautiful interfaces and interfaces that are super fast and almost real-time responsiveness to satisfy our users, of course. And also saving resources is a topic because the energy costs, they will rise more and more, and so also the data center costs will become more and more expensive, and also the cloud costs. I'm really convinced that the costs will increase in the future. And for developers, so we are interested in higher productivity to reduce our development effort and to reduce development time and to have a shorter time to market. That's important for our decision makers who have the budget mostly. Saving costs is really a huge topic. And I'm convinced, so it's because we work more than 15 years on database development tools, working with numerous different databases. We improved imports for all these relational databases supported by Hibernate. And so we got in contact with many customer projects, and performance was always an issue. And also the effort of development, the complexity of the architecture, the complexity of the cache configuration, and so on. And so it came in our mind with Java, actually, we have the best possible performance already. It's because Java has a just-in-time compiler that is able to compile bytecode into machine code through runtime. And with a hot JIT compiler, your Java program will be almost as fast as a C program. And this is really incredible. So we have super fast, we can build super fast applications. With Gravium native images, we are now able to create native executables with Java, which is also incredible. So of course we have some trade-offs, but in terms of the performance, this is really great. This is great news. So nobody can tell us, hey, I've heard Java is slow in comparison to C or C++. So now we can say no. We also can create native images, and they are super fast. And also I don't need to talk about the programming language itself. So everybody knows it's the most powerful programming language on the planet. And we can do almost everything with Java. And this is really important for me. And for this talk also. And we also have a perfect data structure. So we have an object-oriented programming language. Everything is an object. We can create object graphs. With an object graph, we can design data models, complex data models with numbers of relations between our objects, our data objects. So everything is possible. So we can use the object graph for any kind of data structure. So we can use lists, simple lists. We can use key value. We can also keep documents in memory and manage documents like JSON or XML in memory. It's not a problem. This is no issue for us. And we can combine everything together. We can combine it in an object graph. We can use inheritance. Everything is possible. Circular references, and it's in memory. And in memory, it's super fast. So, and Java also provides us a query language, kind of query language with Streams API. So we can search these object graphs in memory. Really convenient. This we had a great talk at on Tuesday about Java Streams, and searching object graphs with Streams API, filtering, no matter how complex it is, how complex your object model will be. We talk about microseconds. So searching, filtering on object graphs in memory takes only microseconds. In comparison, a database, and it's no matter which database you use, we talk about milliseconds. And even when we use an in-memory database, then we also talk about milliseconds response time. Why? It's because they run on remote servers, on remote database servers, and we have the network between our apps and the in-memory databases mostly. So the exception would be if you run your in-memory database within the same JVM process of your app, then it's also super fast, of course. But the most in-memory database approaches are servers. They run on their own machines. And this is the reason why the performance is not comparable with real memory performance. And then on top of that, no matter which database you use, you don't get objects back from databases, which means the object has to be generated. And this time delay you have to add to your query time. And this is the reason why databases are performed in milliseconds, database queries. Which means with Java in memory, we are up to 1000x faster, sometimes even faster than 1000x. It's incredible, but that's truth. It's because memory is that fast. Here we have some numbers. So if you have access to a hard disk, so we talk about milliseconds, SSD are much faster. So we also here have microseconds access time. But access directly to DRAM is the fastest, sometimes only 1000x faster, sometimes 100,000 times faster than disk access. That's great. So this in-memory approach is so incredible fast that actually with only one single machine, it should be possible to replace a complete traditional database cluster. This would save lots of infrastructure costs. It was also reduce the complexity of the system dramatically. That looks really great. So I want to have this performance, and I'm sure all of my customers, all of your customers, if they see what is possible with Java, they want, give me that performance. And there was an interesting study from Amazon, and they found out that latency is really expensive. So every millisecond counts. And they found out that 100 milliseconds of latency costs them 1% in sales. So of course, Amazon is a market leader, is a huge platform. And they really have problems if they have latencies. And I'm pretty sure that most of you work on systems, they are also mission critical and performance will be an issue. So why not using that incredible in-memory performance of the JVM? There are so many concerns, and that's okay. I mean, we also, with my team, worked 15 years on database development tools, and we grew up with databases, and they were standard even before Java came up. So this is the reason why we use database systems all the time and everywhere, and nothing will change it. So I want to clarify that. So I really believe in databases, but there are many use cases and many systems can benefit from in-memory computing. But of course, we have concerns. Why? It's databases care for concurrency. That's great, and they care for transactions. So they guarantee us that our transactions are really safe. Consistency. This is always a topic when we talk about database development. Then other database concepts that are used by database professionals like PL/SQL, stored procedures, stored functions, and so on. And by the way, in Java, here we don't use all these native database features. So sometimes it's okay for us when we don't use the native database functions, because hey, we love object-oriented programming, and most of you won't use stored procedures and stored functions, right? But all of the database experts will tell you, hey, use that. So use PL/SQL, use stored procedures and functions. They are much faster. Put the business logic into the database. So in Java, we won't do that. Here are differences, and Java developers already think different in terms of database development. And there are further open questions like what's about distributed systems, and how can I get external applications access to my database? So how should this work? And what's about SQL support? We don't have that in memory with Java, of course. What's about security, administration, and so on? The list goes on and on. With the upcoming NoSQL approaches, we already begun to rethink database development. So we are already think different in terms of database development. It's in this NoSQL database, they introduce completely new data structure, and also transactions. So we rethink transactions. We rethink consistency. We have now completely new data structure like document-based, like JSON or XML, time series databases. We have we have graph databases, and we cannot really compare it with your Java object graphs. They are similar. So I guess I would say this is the most similar approach to Java object graphs. But keep in mind, graph database introduces their own database-specific graph model. This is not compatible with the Java object graph model. Scaling is also a topic, and here we also think different. We know that SQL databases they scale very well vertically, but NoSQL databases, they are focused on scaling horizontally. And also redundancy, data redundancy. So we rethink even data redundancy. So it's super important in relational databases, but in NoSQL databases, So it's acceptable to have redundancies. So because storage is not expensive, so we can do that. So no problem. And with the upcoming cloud systems, container, and microservices, we also began to think completely different. So we have to. It's because the system works completely different in comparison with the monolithic systems. And also persistence is changing with microservices. Now we have a new rule. Each microservice should have its own database. And consistency also. We have services, they are connected, and how can we guarantee transaction safety and consistency through various numbers of microservices. So we have to rethink completely system design and database development anyway. Okay, sounds cool. In-memory data processing, Java is fast. We have great data structure, query language. Okay, but what's about persistence? So in my talk yesterday, there was this question. We have to persist finally our objects, and then we have the same problems again. So how should we persist our object graph? There is a concept that's called system prevalence, and it was I don't know if I can say it wasn't invented. So he wrote an article. Professor Rolf Johnson wrote an article, and you can read it on Wikipedia what system prevalence is. And he describes actually the concept of in-memory data processing. It's an architectural pattern, and it combines to keep the system state in memory and with snapshots to store your objects persistently on disk. And so this will lead to enormous benefits and advantages. It's because the system architecture will be simple. It will be able to use pure Java concepts. No more mappings or data conversion. No more developing your system around the alien database that works fundamentally different from our programming language. So this feels really natural for Java developers, right? Here is a picture of Professor Rolf Johnson on the left side. So we had a great talk with him about system prevalence concepts and pros and cons. So because I mostly talk about the pros, but of course all technologies have cons. But let's have a look on the architecture of a system prevalence or a prevalence system. It's really simple architecture. We have an application or a microservice, the business logic written in Java. Then we have our objects in memory. You can use whatever you like. You can use complex object graphs, all Java types. No requirements to our object model. No requirements to the used types. And by creating the snapshot, the data will be persisted. They will be stored in a binary format in plain files. So this is the initial system prevalence concept. And of course, we can use Java serialization for that, or this was actually the plan to use serialization. And then we get all of these benefits: in-memory data processing, no database required, no more mappings or conversion. In memory, there will be no latency. We can handle really massive workloads yeah, because everything is executed so incredible fast. And it's super interesting that this concept is now also, I don't know, so it's used now by other concepts. It's used all the time because so many systems use snapshot to persist data. But interesting story is that we now have an open JDK project that tries to persist the system state of a hot JVM that is already optimized by the JIT compiler. So to improve and to accelerate the startup time of a JVM. And this is pretty much the same concept. So we store the system state, so the optimized state of the JIT compiler. It's stored persistently on disk, and after the system restarts, the JVM starts and loads the hot system state directly into the memory, and so the startup time can be significantly improved. And great numbers also here. What is possible with that? So perhaps we will use this concept in future in our microservices. We also have GraalVM native images, so we can check out what fits best for us. But interesting is it's the same, pretty much the same concept, but with persisting data, it's a different thing. There are so many cons. Here is a list of all the cons. It's because of the snapshot itself. It's actually not suited to store data, and it's because between the snapshots you can lose data. And if you create a snapshot of the entire system state, which means this is our in-memory database, so then we create lots of traffic on the network. Then also the database size would be limited to the RAM size. If you have huge RAM size in like 20 terabytes or so, then it's okay, then you can do that, but don't create a 20 terabyte snapshot. So nobody want to do that all the time and transfer the data via the wire, via the network. And there are so many other challenges and open questions of this concept that are not answered. They were not answered. So like, what's about garbage collector passes if the RAM size becomes too big? What's about RAM prices? So Ralph Johnson assumed 15 years ago that today RAM prices would be super low and super cheap. But that's not the case. RAM is still expensive. And also, how can I build distributed systems? So there is a concept, a theoretical concept existing. What's about administration, data migration, access by third-party applications, and the list goes on and on. But we worked on this concept. Yeah, too many cons to become popular in practice. So this might be the reason why this concept is not used in practice in terms of database programming. So snapshots, we use all the time snapshots and everywhere, but not for database development, for bigger databases. With Microstream now we have solved all of these issues. We have built a persistence layer that works dynamically and works really great and is already bulletproof, and we have open sourced the entire framework so that you can use it now completely for free, and also in your commercial applications. So it's under EPL. What is Microstream in a nutshell? It's a persistence layer, and we call it a micro persistence, and it's because it's a tiny Java library. It's really super tiny, super small. It has no dependencies. and this runs within your JVM process of your app or your microservice, and enables you now to persist any Java object graph, any size, any complexity, by using any types, any Java types. So whatever you can build with Java, you can persist it. So the only thing is you need a root object, and everything has to be connected to this root object, and then you can store it. So that's it. Super simple architecture and super simple to use. With Microstream, you will never, in practice, you can do that, but in practice, you will never create a snapshot of the entire system state. So Microstream is built for only storing the deltas. Only the changed objects should be stored. Then you create so-called micro snapshots. This will be executed very fast, not too much traffic on the network. So this is really high efficient. Vice versa, when you load or when you restart the system and we load the object graph in the memory, the Microstream initially loads only the IDs of the objects, the object IDs into the memory, and creates the object graph in memory. But as I said, only the object IDs will be loaded. And you, as a developer, can define which object references should be loaded immediately. So if you have very important data that you need instantly, you can, they will be loaded automatically if you do nothing. If you don't want to load data initially, then define it as lazy. Then they won't be loaded. Then only the object ID will be loaded into the memory. And as soon as you call a get method, then the object reference will be loaded, the subgraph will be loaded and will be merged into your object graph automatically. No more object copies. So this is fully object oriented. This is there are no more classic selects. There are no query language needed. So this is pure Java. And so you're able to restore any kind of object graph, any size, any complexity in the RAM, anytime when it's needed automatically. All right, so it's open source, download via Maven. Here you can find the GitHub repo. You can check it out, try it out, and please start us. So for us, it's a great motivation if Java developers use it. So it's because it's our passion. So we love Java and open source. We love working on open source, and this is really great if you start us. And so we can see we have done a good job for the Java community, and we can give some back to the Java community. Microstream is well integrated into project Helidon, and thanks to the Helidon team, they were the first. They have integrated Helidon with Microstream, and we have built a beautiful integration together. Also, Microstream is now integrated with Micronaut. And here we also, the Micronaut team has put so many work into this integration, and I think we have built a beautiful integration seamlessly into Micronaut. Yeah, check it out, use it. So great frameworks. Everything is open source. And now let's have a look on how the architecture looks like. It's really the same with this system prevalence architecture. Because we follow it. Here we have our application or a microservice. We keep the object graph in memory. We have Microstream. We run a JVM or a native image. And the only thing we need is a plain file storage. So this app can run almost everywhere. You can run it in a container. You can run it on virtual machines. Wherever you like. You also can run a GraalVM native image. So Microstream works with GraalVM native image. And then you can choose your file storage. You can choose plain files. This in the cloud, of course, will be the cheapest way to store data. But we also provide database connectors to common databases. it makes sense to use AWS S3 or other blob storages in other clouds. But you also can use, if you like, a relational database because it's possible to store blobs. So you can use it. We also have connectors to in-memory data grids, distributed caches, and Kafka or Pulsar. So wherever you want to put the object in, you can use Microstream. And so now it's we have many benefits because there are no more mappings, no more conversion. This is eliminated. This is not replaced by anything else. So we eliminate all these latencies through every single read and write. We reduced the CPU consumption dramatically. So it's obvious if you don't have an object relation mapping process in the background behind the scenes or a data conversion, you save lots of CPU power and costs in the cloud. And so we have already proven that in some cases it's possible to save up to 90% of infrastructure costs. And this is not Microstream. Microstream is only the persistence engine. We save up to 90% of infrastructure costs because of the power of the JVM. So this is the important thing. And we have microsecond query time. So I mentioned already, it's the JVM power. This is low latency and real-time responsiveness. So here we have a performance demo. I showed it already at JCON, but it's incredible to see how fast it is. Here we have two applications. It's a bookstore demo, 250 gigabyte data. We use an Oracle database. Both applications use an Oracle database. And one application is built with Hibernate and EH cache, and this is a hot EH cache, and the other application is built with Microstream as a persistence. And you can see also the query code, and each query is really executed up to 1,000 times faster, sometimes only 100x faster. Doesn't matter, but it's so many times faster than a comparable JPA query. It's because in-memory runs in the same JVM process of the app. That's clear. So many developers say that's clear, but why don't we use it? So why don't we use the JVM power? You can now do that. Check it out if this is a use case for you, and then you can get this incredible performance. And the interesting thing is, or the cool thing actually, mostly if you have a system that is so much more powerful, then it's so much more difficult to implement. But with Microstream, it's the opposite. It's much more simple to implement it. This is really great. Here we have a list of all the supported storages, and we have now with the latest Microstream version, we launched last week. We open sourced also all of these data storages, these storage connectors. Sorry. So everything is now open source, and under EPL, yeah, you can run it everywhere. You can also use all JVM languages, and you can also run it on Android. This is the same. Pretty much the same implementation for Android. The code is super simple. There is, I would say, I'm convinced there is no database technology out there that is easier to use than Microstream in comparison, because there are no requirements to your classes. So you can really use plain objects, plain Java objects, no annotations. You don't have to implement any interface. You don't have to use a superclass, nothing. So really plain Java objects. And in terms of the object model, you can really do everything. So you can build your object model completely freely. So it depends really on you. There are no requirements. If you want to persist data, just call one store method. So it's only a store method. The only thing you have to keep in mind is you have to call the store method on the owner object. So for example, if you want to store an object that you have changed in the collection, then you have to store the collection. But don't be afraid. Microstream will not store the entire collection. Only the changed objects will be stored persistently on disk. Each store is an atomic all or nothing operation, and Microstream stores the binary data appended to your file storage. We never overwrite a record like SQL databases do. So we never overwrite data. All stores will be stored appended to your file storage. Alert, my file storage gets bigger and bigger. Yes, that's the case, but with Microstream you have a kind of like a garbage collector for the file storage, and we remove the legacy objects from the file storage. And legacy objects can occur if you change your class model. So if you change a class, you add some fields, remove fields, you change data type, then your class will change, your object will change, and then through runtime, Microstream recognize automatically if a class has changed. It can map the changes automatically. So simple changes are really easy to handle. So simple changes are you add a field, remove a field, you rename a field, you change a primitive data type, can be solved by Microstream automatically. And then you store the object again, then you have a new version of your object in the storage. In the old object, the legacy object will be removed from your storage by the garbage collector. So this is highly configurable, that works really stable and great. All right, loading objects. This is the only thing you have to do is you have to define your classes as lazy. If you don't want to load the objects immediately, instantly through your system start. And it's recommended for microservices. If you want to build a monolithic application, you start it and run it for 3 years without shutdowns, then yeah, you can load everything in the memory, of course. If you want to build a microservice that's tiny, starts super fast, then define all of your legacies, if your lazy references, object references as lazy, and then Microstream only loads the object IDs to identify the references. We have no query language invented, unfortunately. Fortunately, because we have the best query language with Streams API. You can also use GraphQL, for instance, by the way, and GraphQL is also suited to allow external application access to your in-memory database, to your object graph. So this problem is also solved. There are some rules and some challenges, of course. It's concurrency. That's true. So we work on an object graph, so multiple user instances work on an object graph, so you have to care for concurrency. But Java provides also functionality for that. You can use synchronize. So everything that's possible, that's provided by Java, you can use. So should be not really a big deal. There are other rules and challenges and pros and cons, of course, also cons. Let's talk about the cons. You have to think completely different, but you have to think completely different anyway when you build microservice architecture, right? And it's because the traditional database server paradigm works fundamentally different. The database runs on a remote server. The database is located on a remote server, and the persistent data also. And this is the difference. Only the result sets will be on inside the JVM process of your app or microservice. With Microstream, it's completely different. The database is in memory. This is your single source of truth. It's an in-memory database, and but it's also important. It's not a database system. It's an in-memory database, but we have no in-memory database system. So, and the legacy and only the storage data are located anywhere else, like in S3 or on disk. So that's the difference. And then we also think about memory. We have enough. If you have enough memory, then of course you can load your entire database. If you want to do microservices, you shouldn't do that. If you don't have enough memory, use lazy loading. So I've explained it already. Then Microstream, as it is built to be a single node storage. So you should use only one storage for your system state, for your object graph. What you can do is, of course, you can store data into various storages. You can shard your object graph. This is possible, no problem. What you can do with Microstream today is to use multiple instances of your app or microservice and store and use the one and the same storage. But this problem, this trade-off is now solved. Now it's possible also to build distributed apps and microservices with Microstream. And we introduce now object graph replication, and the Microstream cluster provides object graph replication. It's a little bit similar than in-memory data grids or distributed caches. They use hash map, a distributed hash map. With Microstream, you have pretty much the same, but you have not a hash map. You have a real Java object graph that is distributed through hundreds, if you like, through hundreds of JVMs. So this is now possible with Microstream. And a Microstream cluster is much much smaller and much more efficient in comparison to a traditional cluster architecture. Here we can see traditional cluster architecture. You have three clusters mostly in practice. So you have a distributed application. So you have multiple instances of your apps or services. Then mostly you have a database cluster. You run your database on multiple machines. And it's because it's not fast enough in practice. You will have a local cache in your machines. And here you have challenges in terms of consistency. This is the reason why you will have mostly a distributed cache that runs also on multiple machines. So you have, this is standard, a common traditional cluster architecture. In many projects, we have additional clusters like Elasticsearch for faster searching. But that's an example. With Microstream, it's different. It's because it runs within your JVM process. We cluster with object graph replication, we cluster automatically your app or your microservice. So you get a distributed application out of the box by using a Microstream cluster. And that's it. There is no more local cache needed because everything is in memory already. And with this object graph replication, you don't need a distributed cache anymore. And you don't need a distributed database system running on multiple machines. So it's so many machines eliminated. This is super efficient. It handles really tremendous loads in comparison to classic solutions, and you can save tons of cloud costs. And it's pure Java. And as I said, it is even simpler to implement. It's so much simpler to implement in comparison to object relational mapping, additional caching clusters and cache configurations. Great stuff. But you should check it out if this fits for you. As I said, we work on Hibernate tooling as well, so we will continue working on Hibernate, improving it. You have the choice. You can choose whatever you like. It's open source, and so now I'm convinced this is with Microstream the missing piece of puzzle to all these features provided by Java naturally or natively. And now we are able really to build the Warp 36 high-speed applications with pure Java. So check it out if you want to get started. There is also a course on Friday. The learning curve is really flat. It's super easy to learn. With Alliance in Munich, we built an application. We saved more than 90% cost of infrastructure. So this is not the buzzword. This is really the truth. We have a great manual. You can start from GitHub. There are examples, and send us your comments, please. That's super interesting and super important for us. If you want to book a course, we provide in cooperation with JAVAPRO, we provide online training courses for microservice frameworks like Micronaut, Helidon, OpenLiberty, Quarkus, GraalVM, Spring Boot, and Microstream, of course. You can book these courses for free of charge. Just enroll. We have this year more than 100 seats left, and so feel free to book a course. Thank you for joining, and I wish you a great evening at JCON. And I go back to Richard. Thank you very much for joining. Thanks for having me.
Thank you, Markus. Great overview. We got a lot of questions in the chat. Unfortunately, we're at the end of our window. I already wrote to the chat that we have a workshop coming up with you, I guess, on Friday, and there's also a session tomorrow morning if you want to get up and get your Microstream on at 9 o'clock. And I think it's okay for you, Markus, if you stay in the channel for a little bit longer. Maybe you can answer some of the questions. I've seen one of your colleagues has also started answering questions here.
It's my pleasure.
Yeah, so we will go on with the conference, and you can just answer those questions here, or you can take those questions to the sessions tomorrow or on Friday.
I will stay here. Thanks.
Thanks again, Markus, for being here, and for all of you, thank you for being with JCON. And we will continue our 5 tracks in a few minutes. So see what's there and what's interesting to you. And thank you for joining JCON.